Hello everyone, I'm going to go through the answers to the MathsWatch homework which I set a few days ago. Question 1. Select which of the following are surds. So, we know that 36 is a square number because 36 is 6 squared. So root 36 is 6. Root 36 equals 6. So this one is not a surd. So I write not NS, not surd. This one, we know that 10 multiplied by 10 is 100. So root 100 is 10. However, the other three, I can't see any square numbers. So we're going to say that, let me change the colour. This is a surd. And these two are surds as well. Question 2. Root 11 multiplied by root 11. So that's just 11. Remember, square root of a, for example, multiplied by square root of a equals a. And so for the second one, we know that these two values multiplied together gives you 5. And square root of 2 multiplied by square root of 2 is 2. So the total is then 10, as in 5 multiplied by 2 is 10. For the next one, we have 6 multiplied by root 6, which you can't simplify any further. It's just 6 root 6. Question 3. We know that 12 is the same as 4 times 3, so I'll write 4 times 3 underneath the radicand. So we can then write square root of 4, square root of 3. We know that square root of 4 is 2, so I'm going to write 2 root 3. For the next one, okay, let's think of which numbers multiply together to give you 27. I know that 9 multiplied by 3 gives me 27. Square root of 9, square root of 3. Square root of 9 is 3. And square root of 3 is a surd. We can't simplify it any further. 50, okay, we can use a few different numbers. Let's say 25 and 2. Root 25, root 2. I know that root 25 is 5. And so this is our answer. Question 4. Simplify the following surd expressions. So this is the same as if you were to do 5x take away 2x. 5x take away 2x is 3x. So we use the same logic for this question. 5 lots of root 5 take away 2 lots of root 5 is 3 lots of root 5. Using the same logic for the following question, 8 lots of root 7 plus 3 lots of root 7 is 11 lots of root 7. Moving on to question 5. So it says simplify the following. So I know that this can be rewritten like this. Square root of 9 is 3. Square root of 25 is 5. Let me change the colour. Square root of 12, well, we actually worked it out here. Look, square root of 12 is 2 root 3. So I'll write here 2 root 3 over root 3. Now, just like any other, just like with any other fraction, these two values cancel out. And the answer is just 2. Square root of 15 is, I can write square root of 5, square root of 3 over square root of 3. Again, I selected the 5 and the 3 on the numerator because 5 times 3 is 15, equals, these two cancel out. So we have this as our answer. Question 6 looks quite similar to question 4. So essentially it's similar to 5x take away 6x take away 5x, which is just x. Here we have 6 lots of root 2 take away 5 lots of root 2. The answer is root 2. For the next one, we have root 11 plus 3 root 11. So we have 4 root 11. Question 7 is, again, a follow-on to the previous question we just done. There's just a few more values to work with. So imagine you had 7x take away 2x plus x take away 3x. It's just slightly longer than the previous question. 7x take away 5x is, 7x take away 2x is 5x. So we have dealt with these two, we're at 5x. Plus x gives you 6x. 6x take away 3x is 3x. So I'm gonna just write 3 root 3 here. For the next one, 5 root 7 plus 4 root 7 is 9 root 7. So 9 root 7 take away 8 root 7 is just root 7. Remember, root 7 is the same as 1 lot of root 7. We just don't need to write the 1 at the front. The next one is like having 2 variables. So I'm going to write underneath it 9x take away 4x plus y plus 2y. The answer here will be 9x take away 4x is 5x, and y plus 2y is 3y. So I'm going to use the same procedure for the above question. 9 root 3 take away 4 root 3 is 5 root 3. Root 5 plus 2 root 5 is 3 root 5. Ten root 2 plus 4 root 7 take away 6 root 2. So 10 root 2 take away 6 root 2 is 4 root 2. And we have a plus 4 root 7, which is just going to be hanging on at the end because there aren't any other root 7s in this question. Moving on to the indices question. So question 9, it says 2 times 2 times 2. Write this using index notation. So we need to write it as a power, 2 to the power 3, and in this case the 3 is the index. For the next one, let's just count the number of 3's there are. 1, 2, 3, 4, 5. So this equals 3 to the power of 5. Here we have, I can see 2 values, so I have a 4. So we have 3 4, so I write 4 to the power of 3. and we have two 5s, alright, multiplied by 5 to the power of 2, or 5 squared. For the next one, they've just mixed it up a bit, so you have 1, 2, 3, 4, 9, so 9 to the power of 4, and we have two 7s, so 7 squared. Question 10, we need to simplify these expressions. So it's perhaps quite small, so I'll zoom in a bit here. Okay, so here we have 4, 9 plus 3. Remember, when you're multiplying powers, you need to add the indices. Same process for the second one. We get 5 plus 2 equals 6 to the 7. When you're dividing powers, you need to subtract the indices. So 8 is the same as 8 to the power of 1. So the answer to this question would be 8, 6 take away 1 equals 8, 5. 7 to the 8 divided by 7 to the 6 is, because it's a division, we're going to subtract the indices. 7 squared. Let's move on to question 11. It's just a follow-on, same type of questions here. 3, 2 plus 2 equals 3 to the 4. Remember, 7 is the same as 7 to the power of 1. So we're multiplying powers, they have the same base. And so the answer would be 1 plus 4, as in 7 to the power of 1 plus 4, which is 7 to the 5. Here we're dividing powers, so we are taking away 7 from 9. 10 squared. 5 is the same as 5 to the power of 1. We're dividing the powers with each other, so as in we're dividing 5 to the 8 by 5 to the 1, so we need to subtract 1 from the 8. So our answer is 5 to the 7. Put these in order, starting from the smallest. So 1 times 1 times 1 times 1 times 1 8 times is just going to be 1. 1 to the power of anything is 1. Think about it. 1 times 1 is 1. No matter how many times you multiply by 1, the answer will always be 1. Let's focus on this one. 2 times 2 times 2. Let me write it here. Yeah. That's 4 times 4, which is 16. 3 times 3 times 3 equals 9 multiplied by 3, which is 27. And lastly, 5 times 5 equals 25. So we need to put in order from smallest to largest. So 1 to the 8 is the smallest, followed by 2 to the 4, followed by 3 to the 3, followed by 5 to the 2. Moving on to negative indices. I'll zoom in again because the indices are quite small. So 3 to the negative 2. Remember the effect of this negative here, this minus sign. It flips the 3. We need to write the reciprocal of the 3, which is 1 over 3. And we keep the 2 there. We keep the squared. And so 1 over 3 squared is... 1 over 3 squared is 1 over 9. Just want to have more space to work this out. So here we're going to have 1 over 4 to the power 3, which is 1 over 4 times 4 times 4. So let's just write that quickly. Equals 1 over 16 times 4, which is 1 over 64. Again, you'd be allowed more time to work that out, and you don't need to do it in your head, because it's easier to make mistakes when you do it in your head. Here we have 1 over 2 to the 6, which equals 1, and this is the same as 1 over... Okay, we'll do it like this. This is the same as 2 squared 3, which is 1 over 4 to the 3, which is 1 over 64. Alternatively, you could do it the longer way, which is just to do 1 over 2 times 2 times 2 6 times. But I found a shorter way, and it's one which will help you with harder questions in the future. Of course, if you don't understand this, it's just fine to do it this way as well, which will lead you to 1 over 64. Question 14, very, very similar. Here we have 1 over 4 to the power of 1, which is just 1 over 4. Question 14b. 1 over 2 to the 3, which is 1 over 2 times 2 times 2, which is 8. And lastly, we have 1 over 3 to the 4. Now again, you could work it out by doing 1, 3 times 3 times 3 times 3, but I think a shorter way of doing it is doing what I did for the previous question. So I'm going to write it like this: 1 over 3 squared 2, because 2 times 2 is 4. So I know that this is the same as 1 over 9 squared. And I'm going to do 9 times 9. I can do that in my head, which is 81. Question 15, a bit more tricky. But in a sense, we just have to work backwards. So if 5x is 1 over 125, find the value of x. So firstly, we know the x has to be a negative value. It has to be 5 negative something equals 1 over 125. Yeah, 125. So we need to think about how you get from 5 to 125. So 5 times 5 is 25. 25 multiplied by 5 is 5 to add. It's actually 125. So we know that 5 cubed is 125. So 5 to the negative 3 equals 1 over 125 because of that negative sign. So the answer to this question is x equals -3. So x equals -3. For part B, we need to write 1 over 3 to the power 3 multiplied by 1 over 10 to the power 3. So we have 1 over 27, and 10 times 10 is 100, 100 times 10 is 1000. And 1 over 27 multiplied by 1 over 1000 is just 1 times 1 over 27 times 1000. So the answer, the final answer, is 2700. So 1 over 27,000. 2, we know it's going to be 2 to the negative something. So now we need to think about how we get from 2 to 32. 2 times 2 is 4. 4 times 2 is 8. So that's 2 cubed. 2 to the 4 will be 8 times 2. 2 to the 5 will be 16 times 2, which is 32. So 2 to the 5. So 2 to the 5 is 32. 2 to the -5 is 1 over 32. So the value of x is -5. Now let's work out the other one. 1 over 2 cubed multiplied by 1 over 9 squared. Sorry, 3 squared. 3 squared equals 1 over 8 multiplied by 1 over 9. 1 times 1 is 1. 8 times 9 is 72. Question 17 is linking surds with negative indices. So 5 to the -2 is 1 over 5 squared. Cube root of 8 means which number multiplies by itself 3 times to get 8. And this number is, of course, 2. So we have 1 over 25 multiplied by 2, which as a fraction can be written as 2 over 1. And so we have 1 times 2 on the top, which gives us 2. 25 multiplied by 1, which gives us 25. Moving on to question 18. Here's where we start doing questions on Pythagoras. Work out the lengths of A and B. So to work out A, we need to do 8 squared plus 5 squared, which equals 89. But now we know that this A squared, the hypotenuse squared, is equal to 89. So to work out what A is, we need to work out the square root of 89. And it says give your answers to one decimal place. So we type square root of 89 into a calculator. And the answer to one decimal place is 9.4 centimeters. For this question, we have a hypotenuse. So let's think about how we're going to work out, because it's going to be slightly different to the other one. Let's label our triangle C. Here's B, of course, and here is A. So remember, the original formula was A squared plus B squared equals C squared. But what if you know what C is, and so you know what C squared is, you know what A squared is, and you want to work out B squared. So to work out B squared, you need to subtract A squared from C squared. So B squared equals C squared, take away A squared. So here we're going to do 17 squared, take away 12 squared, which equals 145. Remember, you'd be allowed to use a calculator for these questions. B squared equals 145. So B equals square root of 145. If you type this into a calculator, the answer is, to one decimal place, the answer is 12.0. It's 0.4, so I'll just write 12.0 centimeters. Question 19 is very similar to the previous one. We know the hypotenuse, and we need to work out the length of one of the shorter sides of the rectangle. So we're going to do 14 squared take away 7 squared, which is 147. We know that x squared is equal to 147, so we need to square root 147 to work out what x is. Square root of 147 is 12. So just this, something like this here. So we'll just round to 2 decimal places just to be safe. 12.12 centimeters. Now we are back to working out the hypotenuse. So we need to do 16 squared plus 7.5 squared. When you type it into a calculator, you get 312.25. So x squared is 312.25. Sorry, x squared. Yeah, x equals the square root of 312.25. If you type it into a calculator, you get 17.67059, and it goes on and on and on. But, sorry for that. But let's just round to 2 significant figures. And we will write, let's do approximately 17.67 centimeters. In case you have not seen this symbol before, this means approximate to. So the equal sign means equal to, and this equal sign with curved lines means approximate to. So when we round, we could write this as well. The last 4 questions in this homework were the most difficult, and they are all problem-solving questions. So generally in past papers, in exam papers, the hardest questions are problem-solving questions. So let's do these ones as well. Calculate the length of AC to 1 decimal place in the trapezium below. I'm going to split the trapezium into 2 shapes, a rectangle and a right-angled triangle. Now I know, so AC, which one is that? Okay, AC is this line. So in order to work out AC, we need to know the length of CD. So I'll call it X for now. And bearing in mind, X is also, I'll use black actually, X is here, as in X is the length of B, I don't know, M, let's call this M. X is the length of BM, and it's also the length of DC. And let me just, for consistency, use the same color here as well. Alright, so in order to work out X, we need to use the triangle ABM. If this is 4 and this is 11, then we know that this length here is 11 take away 4, which is 7 centimeters. So we can use Pythagoras' theorem on that top right angle triangle to work out X. So I'm going to write 16 squared take away 7 squared, which equals X squared. By using a calculator, we can work out 16 squared take away 7 squared is 207. So X squared is 207 and X is square root of 207, and I could round, but I don't want to because I don't want to lose accuracy. I'll just round at the end. Don't ever round in the middle of answering a long question. Always round at the end. I'll keep it in this surd form. So now we know what X is. Let me rub this off and write okay, now we can work out what AC is by using Pythagoras' theorem with these two values. So I'll write 11 squared plus 207 squared, which is 121 plus 207, which is 328. So the length AC is square root of 328. By typing it into a calculator, we can work out the value to one decimal place, which is 18.1 centimeters. Find the area of the isosceles triangle. So remember that this symbol means that the two lines are the same size. So they have the same length. 13 centimeters is here as well. And find the area of the isosceles triangle. So in order to work out the area, we need to work with right angle triangles. So I'm going to draw a line going through the middle of this isosceles triangle. Now we need to work out the height of these two right angle triangles. So let's call them, I don't know, X and Y. We need to work out the height. So let me cross this out here and write 5 centimeters here, 5 centimeters here. And now we need to use Pythagoras' theorem. So Here is my hypotenuse, here is the other length. I need to work out this h, this height. 13 squared take away 5 squared equals height squared. 13 squared take away 5 squared is actually quite a nice number. It is 144, which is a square number. So height squared equals 144. Height equals 12, because the square root of 144 is 12. So we worked out our height. Now we need to work out the area of the isosceles triangle. So we have two right angle triangles. So I will write area of x equals half times base times height. So it's half times 5 times height, which is this, which gives us 30 in total. Bear in mind, these two triangles are exactly the same. Their measurements are exactly the same. It's half times base times height for this one as well. That equals 30 as well. And so the area of the isosceles triangle is 30 plus 30, which is 60 centimeters squared, because it's an area. Moving on to question 23. Now I'm aware that a lot of students may find these questions really difficult, but I'm going to go through them anyways, because you hopefully will be able to see how you can answer these types of questions after I go through it. So it says a circle has diameter 11 centimeters. They've drawn it for us as well. And a square has side length 7 centimeters. Use Pythagoras' theorem to show that the square will fit inside the circle without touching the edge of the circle. So they're saying prove that the square fits inside the circle without touching the circle, the edge of the circle. A challenging question, and one which is really difficult to do through MathsWatch. However, I'm sure that it can be done. If you place a square within a circle, let's think about the diagonal length within this square, because the longest length will be the diagonals within the square. So our square is 7 centimeters by 7 centimeters. It has lengths of 7 centimeters. So let's work out this diagonal here. The diagonal within the square is going to be, let's just say x for now, 7 squared plus 7 squared, which is 49 plus 49, which is 98. So x squared is 98, and x is square root of 98. Square root of 98 is 9.899, and I'll just stop there. I'll leave it to 3 decimal places. So the diagonal length, the longest length within the circle, is going to be slightly less than 10 centimeters. Now I want you to think about a circle, and here it says that the radius is, the diameter is 11 centimeters. What does diameter actually mean, though? Diameter is the length from one side of the circle to another side. So not only is this 11 centimeters, but going from this point here to this point will be 11 centimeters. Going from this point to the point on the opposite side is 11 centimeters. Going from here to here is 11 centimeters, and so on and so forth. So if I were to draw this square again within a circle, the diagonal length is slightly less than 10. This is, I'll write 9.9. And it's the same going the other way, 9.9 from this side to this side. It's less than 11. Here to here is 11 centimeters. Trying to draw it without making it look too messy. Let's just draw it like this. That's 11 centimeters. The length from here to here is 11 centimeters. And so there is no way the square will touch the edge of the circle, because 9.9 or 9.89, this value is lower than 11 centimeters. It's less than 11 centimeters. Let's read question 24. It says a rectangular gate is made of 6 straight pieces of steel. So we have one piece here, 2 piece, 3, 4, 5 and 6 going through the middle. So those are the 6 pieces of steel. The weight of the steel is 2.5 kg per meter. Work out the total weight of the steel gate. Okay, so we need to work out the perimeter of the rectangle. So we know this is 5 and this is 12. So on top of working out the perimeter, we need to work out the length of these 2 diagonals. So when I say these 2, I mean from one end to the other. So this is one and this is the other, and they're going to be the same size because it's a rectangle and diagonals within a rectangle are the same size. So let's work out the length of the diagonals. 5 squared plus 12 squared equals, let's just call it x for now, equals x squared. 5 squared plus 12 squared is, x squared equals 169. Let me just, 144. Okay, yeah, that's right. So x equals square root of 169, which is 13. So we know the length of our 2 diagonals. Now let's count how many meters of steel we have in total. So 5 plus 5 is 10. 10 plus 12 is 22. 22 plus this is 34. 34 plus, sorry, I'll have here 34 plus 13 plus 13, so alright, 26, is 50, oh no, it's 60, so 60 meters in total. So we have 60 meters of steel, and here it says the weight of the steel is 2.5 kg per meter. So now we need to use our knowledge of ratios. 2.5 kg for 1 meter. Here I write 60 meters. How do you get from 1 to 60? You need to multiply by 60, of course. So here we need to multiply it by 60. 2.5 multiplied by 60 is 150. So the total weight of the steel gate is 150 kg.